Hello students, welcome to your channel Parivartan Physics. We are in the series of videos where we are going through a course called as Rapid Revision course for KCET 2025. Till now we have completed up till ray optics, and in this series of videos we are seeing the concepts, shortcuts and formulas related to each chapter, one chapter in one video, right? So in this video we are going to see in detail about wave optics. I have solved KCET PYQs on all these second PUC chapters, and you can find the link of that playlist in the description box of this video, right? So you can watch the KCET PYQs also. Okay, without delaying, let us start the chapter then, wave optics. See, first, what is a wavefront? Wavefront is locus of all the particles which are vibrating in same phase. The phase difference between them will be zero, right? Which are vibrating in same phase means the phase difference between the particles which are vibrating will be zero. They are oscillating in or vibrating in same phase. Okay, if the source is point source, then what type of wavefront will be there? Spherical wavefront. If it is a line source, cylindrical wavefront. If it is a parallel beam of light, plane wavefront. So there are three types of wavefront: spherical, cylindrical, plane. Point source, spherical; line source, cylindrical; parallel beam, plane wavefront. Okay, next, how the light rays will be with respect to the wavefronts? Rays are always perpendicular to the wavefront. Wavefront ಮತ್ತು light rays ಹೆಂಗಿರ್ತಾವ? They are always perpendicular at every point of intersection, right? Next, Huygens principle. It is used to construct a new wavefront after time t. Okay, ಈಗ ನಮಗೊಂದು ಫಸ್ಟ್ wavefront ಅದ ಅಂತ ಇಟ್ಕೋರಿ. For example, like this, the light rays are going from a point source. This is the point source ಅಂತ ಇಟ್ಕೋರಿ. Then let me say here is the first wavefront. ಇದು ನಮಗೆ ಫಸ್ಟ್ wavefront ಅದ. At every point the light rays will be perpendicular to the wavefront. Light rays will be perpendicular to the wavefront. After time t, if I want another wavefront, then to construct the secondary wavefront, we use this principle called as Huygens principle. What does this states? It tells us that it explains refraction, reflection, diffraction and interference of the light waves, right? It will not explain the polarization. Next, could not explain photoelectric effect and Compton effect. Huygens principle could explain these phenomena of light, but it cannot explain the photoelectric effect and Compton effect. Okay, and next, secondary wavelengths spread out in all directions with the speed of light. ಈ ಸೆಕೆಂಡರಿ ವೇವ್ಫ್ರಂಟ್ಸ್ ಏನಾಗ್ತಾವೆ ಎಲ್ಲ ಡೈರೆಕ್ಷನ್ ಒಳಗೆ 360 ಡೈರೆಕ್ಷನ್ ಒಳಗೆ ನಮಗೆ ವಿತ್ ದ ಸ್ಪೀಡ್ ಆಫ್ ಲೈಟ್ ನಮಗೆ ಟ್ರಾನ್ಸ್ಮಿಟ್ ಆಗ್ತಿರ್ತವೆ. Okay, what we have to construct, how we have to construct the secondary wavefront? By keeping this as the fresh source, by taking the radius as v into t, we have to draw the sphere at every point, and then we have to draw the tangent. We'll get the secondary wavefront. Theory ಒಳಗೆ ನೀವು ಅದನ್ನ ಕಲ್ತಿರ್ತೀರಿ, you know that. Okay, next I will go for the important concept from this chapter, that is called interference. See what happens when two light waves are coming from two coherent sources. Here S1 and S2 are the two coherent sources. From S1 source there is a wave coming called as Y1. From S2 source there is a wave coming called as Y2. These both waves are getting superposed at this point P, and they are forming a resultant wave called as Y. Right? Two waves are getting superimposed. ಎರಡು waves superpose ಆಗತಾವ, ಅದರಿಂದ ನಮಗೊಂದು resultant wave ಸಿಗತೈತಿ. Two waves are superposing, we are getting one resultant wave, and that resultant wave is Y. Okay, the first wave y1 is equal to a sin omega t. The second wave y2 is equal to b sin omega t plus pi. Right? These are the two waves. So amplitude of the first wave is a, amplitude of the second wave is b. The phase difference between first wave and second wave is pi. This is the phase difference between the two waves. They are getting superimposed. Right? When these two waves get superposed, by principle of superposition, the resultant wave is given by y is equal to y1 plus y2. This is resultant wave. And this resultant wave will be having an amplitude called as A, and it will be having an intensity called as I. These are called as resultant amplitude, resultant intensity. Amplitude of resultant wave, resultant amplitude. Intensity of resultant wave, resultant intensity. A is the amplitude of Y1, wave Y1. B is the amplitude of wave Y2. Okay, now this resultant amplitude and resultant intensity, most important formulas you have to remember. Resultant amplitude is given by A is equal to root of A square plus B square plus 2AB cos pi. A and B are the amplitudes of first wave and second wave. Pi is the phase difference between the first wave and second wave. And what is the relationship between intensity and amplitude? Intensity and amplitude are related like this. Intensity is directly proportional to the square of amplitude, or root intensity is directly proportional to the amplitude. Correct? Next, resultant intensity. ಈಗ ನೋಡ್ರಿ, where there is a square you can substitute I there. ಎಲ್ಲಿ a square ಅದ ಅಲ್ಲಿ ನೀವು I ಬರಿಬಹುದು. ಎಲ್ಲಿ a ಅದ ಅಲ್ಲಿ ನೀವು root I ಬರಿಬಹುದು. Right? If I square on both the sides, what I will get it as a square is equal to a square plus b square plus 2ab cos pi ಅಂತ ಬರ್ತೈತ್ರಿ ನಂಗೆ. This much I will get. So in place of a square, resultant amplitude square ಜಾಗದಾಗ ನಾ resultant intensity ಬರ್ಕೊಂತೀನಿ. ಆಮೇಲೆ amplitude square of the first wave, intensity of the first wave, amplitude square of the second wave, intensity of the second wave, plus 2 AB intensity, amplitude of first wave, amplitude of second wave. Where there is amplitude, you take root of I there, root of intensity. So it will be 2 root I1 into I2 cos pi, right? So this is resultant amplitude, this is resultant intensity. If the waves are, see, these waves are non-identical. Non-identical andre ena, they are having different amplitudes. If the waves are identical, same amplitude, same intensity around the waves idandre adಕ್ಕೆ identical waves anta karitare. If the waves are identical, then for identical waves, resultant amplitude will be 2a cos pi by 2. At that time, don't use this formula. This is for non-identical waves. This is also for non-identical waves. For identical waves, resultant amplitude is 2a cos pi by 2. Resultant intensity is 4i cos square pi by 2. 4i cos square pi by 2. Correct? Okay. Next, we'll go for relation between phase difference and path difference. See, phase difference is represented by delta pi, path difference is represented by delta x. So relation between phase difference delta pi and path difference delta x. It is delta pi is equal to 2 pi by lambda into delta x. What is lambda? Lambda is wavelength. Lambda is wavelength. It will be in terms of meter. Correct? Okay, next note. Path difference between the two waves meeting at a point. For example, ಈಗ ನಮಗೆ Young's double slit experiment ಒಳಗೆ double slits ಇರ್ತಾವ್ರಿ. Let me say this is slit number 1, this is slit number 2. Correct? And the distance between the two slits is taken as small d. The two light waves which are coming from these will get superposed and the interference pattern will form on the screen. This is the screen. So the distance between double slit and the screen is taken as capital D. Right? Let me say the wave coming from first source and the wave coming from the second source are getting superposed at this point. So that point of superposition is at a distance y from the central reference. Andre central bright fringe dinda adu nಮಗೆ y distance ಒಳಗದ ಅಂತ ಇಟ್ಕೊಳ್ಳಿ. Right? So here the path difference between these two. See, path difference ಅಂತಂದ್ರೆ ಏನ? For example, the 10 meter travel ಮಾಡಿದ್ರೆ ನಮಗೆ 15 meter travel ಮಾಡಿರಬಹುದು. So there is the difference in the path. Right? So that is called path difference. So ಇದು delta x is equal to y into small d divided by capital D. What is y? Y is the vertical distance from the central bright fringe. D, distance between the slits. Capital D, distance between the double slit and the screen. This is path difference. This is relationship between phase difference and path difference. Correct? Okay, let us go for the next concept then. See, these are very important in case of instructions, in case of interference. Two types of interference will take place, we know that very well. Constructive interference, where the intensity will be a maximum, and destructive interference, where the intensity will be minimum. See, resultant intensity, we know already the formula I is equal to I1 plus I2 plus 2 root I1 I2 cos pi. Resultant intensity for non-coherent sources. Nodri, idu coherent sources iddaga resultant intensity ನೀವು ಈ ತರ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು. Non-coherent sources ಇದ್ದಪ್ಪ ಅಂತಂದ್ರೆ maximum intensity means it is I1 plus I2, minimum intensity means it is I1 minus I2. That's it. Maximum means I1 plus I2, minimum intensity I1 minus I2. That is for non-coherent sources. See, for constructive interference, intensity has to be maximum. Intensity maximum or minimum ಎದ್ರ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗ್ತದಪ್ಪ ಅಂದ್ರೆ it depends upon pi value. If this pi is 0, cos 0 will be 1 and this will be plus 2 root I1 into I2. If that cos pi value is 180 degree, then cos 180 will be minus 1, this will become minus 2 root I1 into I2. If it is 90 degree, it will become 0. This complete term ನಮಗೆ 0 ಆಗ್ತದೆ. So it depends upon the value of pi. Pi ಮೇಲೆ ನಮಗೆ ಡಿಪೆಂಡ್ ಆಗ್ತದೆ. So ನೋಡ್ರಿ, interference ಒಳಗೆ ನಮಗೆ constructive interference ಒಳಗೆ intensity maximum ಬರಬೇಕಾದ್ರೆ first condition ಏನಂದ್ರೆ cos pi value ನಮಗೆ 1 ಇರಬೇಕು. We should get the value of cos pi 1. Then if you get cos pi value 1, then this will be plus 2 root I1 I2. So if you want to get cos pi value 1, then the phase difference pi must be equal to even multiple of pi, 2n pi anta namagu barabeku. We have to get it as 2n pi, where n is equal to 0, 1, 2, 3, whatever you substitute. So this much has to be the phase difference and this much will be the path difference. New phase difference, path difference relation ಒಳಗೆ substitute ಮಾಡ್ಕೊಂಡ್ರೆ ಈ phase difference ಅನ್ನು substitute ಮಾಡ್ಕೊಂಡ್ರೆ ಇಷ್ಟು ನಿಮಗೆ path difference ಬರ್ತದೆ. Right? So for maximum intensity, for constructive interference, cos pi must be equal to 1, phase difference must be equal to 2n pi, path difference will be equal to n lambda. Remember the formulas. Okay, now resultant amplitude will be a plus b. Resultant intensity nodri, maximum intensity anta navu ಏನು ಕರಿತೀವಿ, cos pi ನಮಗೆ 1 ಆಯ್ತಪ್ಪ ಅಂತಂದ್ರೆ I will get I1 plus I2 plus 2 root I1 into I2. Right? We are adding 2 root I1 I2 here. Okay, well, you will get to know the difference there. Okay, ಈಗ next ನೋಡ್ರಿ, I can express this as a plus b whole square form. ಇದನ್ನ a plus b whole square form ದ express ಮಾಡ್ಕೊಂಡ್ರೆ it will be root of I1 plus root of I2 whole square, or in terms of amplitude it will be a plus b whole square. So maximum intensity is equal to root of I1 plus root of I2 whole bracket square, or a plus b whole square. A and b are amplitudes of the first wave and second wave. Okay, for destructive interference, intensity has to be minimum. For destructive interference, intensity has to be minimum. Intensity minimum ಇರಬೇಕಿತ್ತಂತಂದ್ರೆ ಇಲ್ಲಿ ನೋಡ್ರಿ I1 plus I2 ಕ್ಕೆ ನಾವಿಲ್ಲಿ plus 2 root I1 I2 ಮಾಡ್ಕೊಂಡಿದ್ವಿ. It means for I1 and I2, for I1 and I2 you have added 2 root I1 and I2, that's why it is said to be maximum. If I subtract this 2 root I1 I2, this will become, this intensity will become minimum. So ಇದನ್ನ subtract ಮಾಡಬೇಕಾದ್ರೆ ಈ sign ನಮಗೆ ಎಷ್ಟು ಬರಬೇಕು? This sign how much it has to be? It has to be what it has to be? It has to be negative, minus ಇರಬೇಕು. So to get it minus cos pi value, we should get minus 1. ಇಲ್ಲಿ cos pi value plus 1 ಬರಬೇಕಿತ್ತೆ, ಇಲ್ಲಿ cos pi value ನಮಗೆ minus 1 ಬರಬೇಕು. Cos pi value minus. See, to get cos pi value plus 1, we took phase difference as even multiple of pi. Even multiple of pi. To get cos pi value minus 1, we should take phase difference as odd multiple of pi. Odd antandre 2n plus 1. This will give you odd number. 2n will give you even number. Right? So this is the odd multiple of pi. If we substitute this phase difference, then we'll get the path difference as delta x is equal to 2n plus 1 lambda by 2. This much path difference we will get. Right? Okay, in this case, minimum amplitude means it will be a minus b, maximum amplitude means it is a plus b. Minimum intensity, nodri idana minus 1 ile substitute madkondre I1 plus I2 minus 2 root I1 I2 will get. This will be in the form of a minus b whole square. So this is root of I1 minus root of I2 whole square, or a minus b whole square. Correct? This is said to be minimum intensity. So here we are subtracting this minus 2 root I1 I2. Nodri ille I1 plus I2 plus 2 root I1 I2 itta, so it is said to be maximum. We are adding there, and here it is I1 plus I2 minus 2 root I1 I2. We are subtracting there. That is minimum intensity. So the ratio of maximum intensity and minimum intensity will be the same formulas we have to take. Root I1 plus I2 whole square divided by root I1 minus I2 whole square, or equal to, in terms of amplitude, a plus b whole square divided by a minus b whole square. Right? So like this we will get it. Okay, that's all about the constructive and destructive interference. Next, average intensity. Average intensity is the average of maximum intensity plus minimum intensity divided by 2, or I1 plus I2. Fringe visibility. Fringe visibility is given by I max minus I minimum divided by I max plus I minimum. 2 root I1 I2 divided by I1 plus I2, 2 A1 into A2 divided by A1 square plus A2 square. In terms of maximum and minimum intensity, in terms of intensity of first wave, second wave, in terms of amplitude of first wave and second wave. Right? Maximum ಈ ಫಾರ್ಮುಲಾ ನೀವು ನೆನಪಿಟ್ಟುಕೊಂಡ್ರೆ ಈ ಫಾರ್ಮುಲಾ ಮೇಲೆ ನೀವು ಇದನ್ನು ಬರೀಬಹುದು. ಇದೇ ಫಾರ್ಮುಲಾ ಮೇಲೆ ನಮಗೆ ಕೇಳಿದ್ರೆ ಕೇಳ್ತಾರೆ. Right? Visibility. Next, width of the slit. W1 by W2 is equal to A1 square by A2 square, or I1 by I2. Width in terms of width, ratio of width in the ratio of amplitude in the ratio of intensity. Remember the relations. Okay. Next, fringe width. See, actually fringe width is a derivation theory ಒಳಗಿಲ್ಲ, but this is useful. You have to take it. You have to remember it. So fringe width is given by beta is equal to lambda into capital D by small d. We know in interference, ಈಗ interference ಒಳಗೆ ನಮಗೆ fringes ಯಾವ ತರ ಫಾರ್ಮ್ ಆಗಿರ್ತಾವ ಗೊತ್ತದ್ರಿ. In interference, in Young's double slit experiment, if this is central bright fringe, next to that a dark fringe will get formed, right? On both the sides of that central bright fringe, dark fringe will get formed. After that you will get a bright fringe, right? Bright fringe. After that you will get a dark fringe. So alternate bright and dark fringes you will get like this. Alternate bright and dark fringes you will get, right? Like this you will get alternate bright and dark fringes. Iga fringe width antandre how much is the width of this or width of this? This is called fringe width. Iduk fringe width anta karitare, right? That fringe width is given by beta is equal to lambda into capital D by small d. Fringe width is directly proportional to wavelength, inversely proportional to the distance between the two slits. Number of fringes formed is inversely proportional to fringe width. If fringe width is more, less fringes will form. If fringe width is less, more fringes will form. Right? Next, note ille beta is directly proportional to lambda. It means if you increase the wavelength of the light, for example, in lambda 1 light ನೀವು ಯೂಸ್ ಮಾಡಿದ್ರಿ ಅಂತ ಇಟ್ಕೋರಿ, ಈಗ ನಮಗೆ fringe width ಎಷ್ಟದರಿ? This much is the fringe width. If I use a wavelength which is greater than this, lambda 2 ಅಂತ wavelength ನ ಏನಾದರೂ ಯೂಸ್ ಮಾಡಿದ್ರೆ ಅದರೊಳಗೆ ನಮಗೆ the fringes will be of this much width. ಇಲ್ಲಿ ನಮಗೆ fringe width ಈ ತರ ಆಗಿರ್ತದೆ. The fringe width will be like this, right? So you can observe here the fringe width has got increased. ಇಲ್ಲಿ ನೀವು observe ಮಾಡಬಹುದು fringe width ನಮಗೆ ಹೆಚ್ಚಾಗಿದೆ. See, the fringe width is this much here and the fringe width is this much here. Why? Because here we have taken the wavelength more. More the wavelength, the width of the fringes will increase. Next, angular fringe width. It is beta, fringe width divided by distance of the screen, or wavelength divided by the distance between the slits. Next, fringe width in liquid of refractive index n. Suppose you immerse that Young's double slit experiment apparatus in a liquid of refractive index n, then the fringe width will get reduced by n times, lambda into capital D by n into small d, beta by n. So fringe width will get reduced by n times when you immerse it in a liquid. Okay, next, see, illa interference pattern na tagondidine. See, you can see here, this is central bright fringe. Next to central bright fringe, we have first dark fringe, first bright fringe, second dark fringe, second bright fringe, third dark fringe, third bright fringe, fourth dark fringe. So bright, dark, bright, dark, bright, dark, like this alternate fringes have got formed. In interference, you remember, all the fringes will be having same width. Ella bright ಮತ್ತು dark fringes width same ಇರ್ತದೆ. All bright fringes will be having maximum intensity. All dark fringes will be having minimum intensity. Right? This is in case of interference. In case of diffraction, the fringes width will not be same. Bright fringes width ನಮಗೆ reduce ಆಗೋತ ಹೋಗ್ತದ್ರೆ as we move from the central bright band, and dark fringes width will go on increasing. Bright fringes are not 100% bright. The intensity of the bright fringes goes on decreasing as we move from the central bright band in diffraction, not in interference. It will be same. Ille diffraction ಒಳಗೆ ನಮಗೆ ಕಮ್ಮಿ ಆಗೋತ ಹೋಗ್ತದೆ. Correct? Okay, ಇಲ್ಲಿ ನೋಡ್ರಿ. Here we have shown intensity. So intensity of all the fringes, you can observe here, all the fringes, intensity of all the fringes is same. Ella fringes intensity ನಮಗೆ same. Numbering system, central bright fringe number ಕೊಡಬೇಡ್ರಿ. First dark fringe n equal to 0, second dark fringe n equal to 1, third dark fringe n equal to 2, fourth dark fringe n is equal to 3. Right? Started from 0. So ಈಗ second dark fringe ಅಂದ್ರೆ 1 ಅಂತ ತಗೊಳ್ರಿ, 10th dark fringe ಅಂತಂದ್ರೆ 9 ಅಂತ ತಗೊಳ್ರಿ, 15th dark fringe ಅಂತಂದ್ರೆ 14 ಅಂತ ತಗೊಳ್ರಿ. Bright fringe, first bright fringe 1, second bright fringe 2, third bright fringe 3, no difference. Dark fringe you start numbering from 0, bright fringe you start numbering from 1. So bright fringe ಗೆ ಏನು ತೊಂದರೆ ಇಲ್ಲ. Third bright fringe ಅಂದ್ರೆ 3 ಅಂತ ಹೇಳಿ ತಗೊಳ್ರಿ, fifth bright fringe ಅಂದ್ರೆ 5 ಅಂತ ಹೇಳಿ ತಗೊಳ್ರಿ. Dark fringe ಗೆ ಮಾತ್ರ 1 ಕಮ್ಮಿ ತಗೋಬೇಕು ನೀವು. Okay, these formulas are at most important. You have to remember these formulas for bright fringe as well as dark fringe. Right? See, path difference delta x equal to n lambda ನಾವು already ನೋಡ್ಕೊಂಡಿದ್ದೀವಿ. For bright fringe, path difference will be n lambda. For dark fringe, path difference will be 2n plus 1 lambda by 2 for dark fringe. Right? Phase difference, for bright fringe it will be 2n pi, even multiple of pi, and for dark fringe it will be odd multiple of pi, 2n plus 1 pi. This also we have seen. Next, very important thing is distance from nth fringe. Distance of nth fringe from central bright fringe. Nodri, ಯಾವುದೇ fringe the distance ನೀವು measure ಮಾಡಬೇಕಾದರೂ ಕೂಡ you have to measure it from central bright fringe. If for example first bright fringe the distance ನಿಮಗೆ ಬೇಕಿತ್ತು central bright fringe ಇಂದ ಅಂತಂದ್ರೆ you have to measure it from here. So this is called distance of first bright fringe. If you want the distance from third dark fringe, this is the distance of the third dark fringe. So all the distances are measured from central bright fringe only. So the distance formula is n lambda into capital D by small d for bright fringe, and for dark fringe it is 2n plus 1 lambda by 2 into capital D by small d. That is for dark fringe. Next, angular position of the fringes. Angular position d sin theta is equal to n lambda for bright fringe, and d sin theta is equal to 2n plus 1 lambda by 2 for dark fringe. Bright fringes will start from 1, dark fringes will start from 0. What is this angular position? See, idan namagu central fringe the reference line ade. If I say this is the third bright fringe and this is the second bright fringe, you can observe the angle difference here. For second bright fringe, for third bright fringe the angle is this much. Third bright fringe the angle is this. And for second bright fringe angle is this much. This angle namagu second bright fringe kadare. This is for second and this is for third. So you can observe the angular position there. Right? So remember these formulas. Okay, next, see, these type of situations will be asked in the question. Here, fringes coincide for different wavelength. Here we have used two different lights of wavelength lambda 1 and lambda 2. ಎರಡು ಡಿಫರೆಂಟ್ ವೇವ್ಲೆಂತ್ ಇರುವಂತ ಲೈಟ್ಸ್ ಯೂಸ್ ಮಾಡಿದೀವಿ. ಆಬ್ವಿಯಸ್ಲಿ ಇಫ್ ಯು ಚೇಂಜ್ ದ ವೇವ್ಲೆಂತ್, ಫ್ರಿಂಜ್ ವಿಡ್ತ್ ವಿಲ್ ಚೇಂಜ್. ಫ್ರಿಂಜ್ ವಿಡ್ತ್ ಚೇಂಜ್ ಆಗ್ತದ್ರಿ. ಫ್ರಿಂಜ್ ವಿಡ್ತ್ ಚೇಂಜ್ ಆಯ್ತಪ್ಪ ಅಂದ್ರೆ ನಂಬರ್ ಆಫ್ ಫ್ರಿಂಜಸ್ ಫಾರ್ಮ್ಡ್ ಚೇಂಜ್ ಆಗ್ತವೆ. ಕರೆಕ್ಟ್? ಸಿ, ಹಿಯರ್ ಇಟ್ ಇಸ್ lambda 1, here it is lambda 2. Here the fringes width is this much. Here the fringe width is increased. It is more. So lambda 2 is greater than lambda 1. This wavelength is more because the fringe width is more here. This wavelength is less because the fringe width is less here. Okay, ಈಗ lambda 1 light use ಮಾಡ್ಕೊಂಡಾಗ ಏನು ನಿಮಗೆ ಪ್ಯಾಟರ್ನ್ ನಂಬರ್ 1 ಸಿಕ್ಕುತ್ತೆ. This is interference pattern 1, this is interference pattern 2. From both the patterns, one bright fringe from this pattern and one bright fringe from this pattern are coinciding. Coinciding in the sense they are at the same distance. They are at the same distance from the central bright fringe. So let the bright fringe in the first pattern be taken as n, and let the bright fringe in the second pattern be taken as m. ಈಗ ಇಲ್ಲಿ ನೋಡ್ರಿ, it is 1 2 3 third bright fringe ada. Ille 1 2 second bright fringe ada. So third bright fringe from the first pattern, second bright fringe from the second pattern are getting coincided. In this case, we have to use this relation lambda 1 by lambda 2 is equal to m by n. Either they will ask you to calculate wavelength or they will ask you to calculate the number of fringe. Correct? This relation you have to use in the coincidence of the fringes when two different wavelength lights are used. Next, distance of nth fringe for different wavelengths. ಈಗ ನೋಡ್ರಿ ಇಲ್ಲೇ ನಾ wavelength lambda number 1 ಯೂಸ್ ಮಾಡಿದ್ದೇನೆ ಅಂತ ಇಟ್ಕೋರಿ. Here I have used light of wavelength lambda number 2. So here the wavelength is more, here the wavelength is less. Correct? So more the wavelength, more will be the fringe width. Less the wavelength, less will be the fringe width. Correct? Okay, you can observe here in the first pattern, third bright fringe has got formed at a distance of x1, and the same third bright fringe for the second pattern has got formed at a distance of x2. So itradu third bright fringe nodri idu namaga kammi distance olagada, itradu third bright fringe nodri it is at a distance x2, right? So in this case the distance of third bright fringe athwa yavada fringe nimagali kottirbodu, distance of the bright fringe in the first pattern divided by distance of the bright fringe in the second pattern equal to lambda 1 by lambda 2, right? This relation you have to use. Okay, next we'll go for diffraction. See, in diffraction we know very well this is central bright band, and you can observe the bright bands are decreasing. The width of bright band illi istittu illi kammi aaytre adakinte illi kammi aaytre. So as we move away from the central bright band on either side, the bright band width goes on decreasing. Width of the bright band decrease ಆಗ್ತದೆ. ಆಮೇಲೆ ನಾಟ್ ಓನ್ಲಿ ವಿಡ್ತ್ ಬಟ್ ಅದರದ ಇಂಟೆನ್ಸಿಟಿ ಕೂಡ ಡಿಕ್ರೀಸ್ ಆಗೋದು ಹೋಗ್ತದೆ. ಸೊ ಸೆಂಟ್ರಲ್ ಬ್ರೈಟ್ ಬ್ಯಾಂಡ್ ಇಂಟೆನ್ಸಿಟಿ ಎಷ್ಟು ಆದ್ರೆ ಅದರ ನೆಕ್ಸ್ಟ್ ಬ್ರೈಟ್ ಬ್ಯಾಂಡ್ ಇಂಟೆನ್ಸಿಟಿ ಎಷ್ಟು ಬರ್ತದೆ, ಆಮೇಲೆ ಎಷ್ಟು. ಸೊ ದ ಇಂಟೆನ್ಸಿಟಿ ಇಸ್ ಡಿಕ್ರೀಸಿಂಗ್. ಇಂಟರ್ಫರೆನ್ಸ್ ಒಳಗೆ ಡಿಕ್ರೀಸ್ ಆಗಂಗಿಲ್ಲ, ಇಂಟರ್ಫರೆನ್ಸ್ ಒಳಗೆ ಎಲ್ಲ ಸೇಮ್ ಇತ್ತು, ಇಲ್ಲಿ ಡಿಕ್ರೀಸ್ ಆಗೋದು ಹೋಗ್ತದೆ. ವಿಡ್ತ್ ಆಫ್ ಡಾರ್ಕ್ ಫ್ರಿಂಜಸ್ ಇನ್ಕ್ರೀಸಸ್, ವಿಡ್ತ್ ಆಫ್ ಡಾರ್ಕ್ ಫ್ರಿಂಜ್ ನಮಗೆ ಇನ್ಕ್ರೀಸ್ ಆಗೋದು ಹೋಗ್ತವೆ, ವಿಡ್ತ್ ಆಫ್ ಬ್ರೈಟ್ ಫ್ರಿಂಜ್ ನಮಗೆ ಡಿಕ್ರೀಸ್ ಆಗೋದು ಹೋಗ್ತವೆ, ರೈಟ್? ದೇ ಆರ್ ಕಾಲ್ಡ್ ಆಸ್ ಮ್ಯಾಕ್ಸಿಮಾ. ಬ್ರೈಟ್ ಫ್ರಿಂಜಸ್ ಅಂತಾರೆ ಇಂಟೆನ್ಸಿಟಿ ಮ್ಯಾಕ್ಸಿಮಮ್ ಇರುವಂತ ಪ್ಲೇಸಸ್, ಅವಕ್ಕೆ ಮ್ಯಾಕ್ಸಿಮಾ ಅಂತಾರೆ. ಡಾರ್ಕ್ ಫ್ರಿಂಜ್ ಅಂದ್ರೆ ಅವಕ್ಕೆ ಮಿನಿಮಾ ಅಂತ ಕರೀತಾರೆ. Okay, width of central bright band, it is given by 2 lambda into capital D by small d. What is capital D? Distance of the screen. What is small d? It is width of that single slit we use in the diffraction, right? Okay, angular width of central bright band, idu width of central bright band, idu angular width of central bright band, it is 2 lambda by small d. Ratio of intensity of successive maximas ಅಂದ್ರೆ ನೋಡ್ರಿ ಇದು central bright band, first maxima, second maxima, third maxima. So these are the maximas. So maximas, the intensity 1 is to 2 by 3 pi whole square is to 2 by 5 pi whole square is to 2 by 7 pi whole square, like this it will be. Width of secondary maxima lambda into capital D by small d. Angular width of secondary maxima lambda by d. Idu 2 multiply ಆಗ್ತದೆ ಇವೆರಡಕ್ಕೂ, ಇದಕ್ಕೆ 2 multiply ಆಗಂಗಿಲ್ಲ ಅಷ್ಟೇ, ಫಾರ್ಮುಲಾ ಸೇಮ್ ಅದೇ, right? Okay, that's all about diffraction. Next ನೋಡ್ರಿ, distance of nth band in diffraction pattern. Interference pattern ಒಳಗೆ ಏನು ಫಾರ್ಮುಲಾಸ್ ಇದೆ ಅವ ಇಲ್ಲಿ ಬರ್ತಾವ, ಬಟ್ ಇಂಟರ್ಚೇಂಜ್ ಆಗ್ತಾವ್ರಿ. ಬ್ರೈಟ್ ಫ್ರಿಂಜ್ ಫಾರ್ಮುಲಾ ಇಲ್ಲ ಡಾರ್ಕ್ ಬ್ಯಾಂಡ್ ಹೋಗ್ತದೆ, ಡಾರ್ಕ್ ಫ್ರಿಂಜ್ ಫಾರ್ಮುಲಾ ಇಲ್ಲ ಬ್ರೈಟ್ ಬ್ಯಾಂಡ್ ಬರ್ತದೆ. ಸೊ ದ ಡಿಸ್ಟೆನ್ಸ್ ಆಫ್ ಬ್ರೈಟ್ ಬ್ಯಾಂಡ್ ಇಸ್ xn is equal to 2n plus 1 lambda by 2 into capital D by small d. Distance of dark band xn is equal to n lambda into capital D by small d. So interchange ಆಗಿದಾವೆ, you can remember it easily. Okay, next is, see, polarization, last concept in this chapter. See, if all types of vibrations are present in a light, then that is called unpolarized light. All possible directions are there, right? All possible directions are here, so it is unpolarized light. If there are only one kind of vibrations present in that light, then that is said to be polarized light. ಈಗ ಇಲ್ಲಿ ನೋಡಿದ್ರೆ ನಮಗೆ ವೈಬ್ರೇಷನ್ಸ್ ಆರ್ ಪ್ರೆಸೆಂಟ್ ಓನ್ಲಿ ಇನ್ ದಿಸ್ ಪ್ಲೇನ್, ಈ ಬೋರ್ಡ್ ಪ್ಲೇನ್ ಒಳಗೆ ಮಾತ್ರ ನಮಗೆ ವೈಬ್ರೇಷನ್ಸ್ ಪ್ರೆಸೆಂಟ್ ಅದಾವೆ. ಸೊ ಓನ್ಲಿ ಒನ್ ಟೈಪ್ ಆಫ್ ವೈಬ್ರೇಷನ್ಸ್ ಆರ್ ಹಿಯರ್, ಸೊ ಇಟ್ ಇಸ್ polarized light. Here also you can check, there are only one type of vibrations, and these vibrations are perpendicular to the plane of the board. This is also polarized light, this is also polarized light, and that is unpolarized light. Only one type of vibration has to be there in that, then it is said to be polarized light, right? Okay, next, see here we know this very well, we are using two polarizer here. ಎರಡು polarizer ಗಳನ್ನು ಯೂಸ್ ಮಾಡ್ತೀವಿ, ಒಂದು polarizer ಅಂತ ಹೇಳಿದ್ರೆ, this is the polarizer, we are naming this as polarizer. Second one is analyzer. Both will be having a character called as axis. ಅವು ಎರಡಕ್ಕೂ ಒಂದೊಂದು axis ಇರ್ತಾವ್ರಿ, ಕರೆಕ್ಟ್? ಈಗ ನಾವೇನ್ ಮಾಡತ್ತೀವಿ, this is unpolarized light, so we are passing unpolarized light through polarizer. What happens, this unpolarized light when passes through the polarizer, only the vibrations which are parallel to the axis of the polarizer, ಆ polarizer ದ axis ಗೆ parallel ಇರುವಂತ vibrations ಮಾತ್ರ ನಮಗೆ ಅದರಾಗಿಂದ ಪಾಸ್ ಆಗಿ ಹೊರಗೆ ಹೋಗ್ತವೆ. Remaining vibrations will be blocked by this polarizer. ಉಳಿದ vibrations ಎಲ್ಲ polarizer ದಿಂದ ಬ್ಲಾಕ್ ಆಗ್ತವೆ. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್, ಈಗ ನೀವು ರೆಡ್ ಕಲರ್ ಸ್ಪೆಕ್ಟ್ ಹಾಕೊಂಡ್ರೆ ನಿಮ್ಗೆ ಎಲ್ಲಾನು ರೆಡ್ ಕಲರ್ ಕಾಣಿಸ್ತದೆ, Red color goggle hakonಡ್ರೆ ಎಲ್ಲ red color ಕಾಣಿಸುತ್ತೆ. It will block all other colors. It allows only red color inside. Like that it is, right? So unpolarized light ಒಳಗಿರಂತ ಉಳಿಕಿದ್ದೆಲ್ಲ vibrations ಅನ್ನೋದು ಏನು ಮಾಡ್ತದ್ರಿ? It will block and it will take only the vibrations which are parallel to the polarized light. So if intensity of unpolarized light is I naught, then the intensity which is coming out from the polarizer is I naught by 2. I naught by 2. Next, this is analyzer. If the axis of analyzer is exactly parallel to the axis of polarizer, then polarizer daginda ಎಷ್ಟು intensity ಹೊರಗೆ ಬಂದಿತ್ತ I naught by 2 ಅಂತೇಳಿ ಸೇಮ್ intensity ನಮಗೆ ಈ ಕಡೆ ಬಂದ್ಬಿಡ್ತದೆ. Analyzer daginda ಹೊರಗೆ ಬಂದ್ಬಿಡ್ತದೆ. If axis of both of them are parallel. Now, if the analyzer is been rotated, analyzer ಸ್ವಲ್ಪ rotate ಮಾಡಿದ್ರು, ಎಷ್ಟೋ ಒಂದು angle ನಮಗೆ ಇಲ್ಲಿ rotate ಮಾಡಿದಾರೆ ಅಂತ ಇಟ್ಕೋರಿ, pi ಅಂತೇಳಿ ಎಷ್ಟೋ ಒಂದು angle rotate ಮಾಡಿದಾರೆ. So as you go on rotating the analyzer, the intensity goes on reducing. Intensity reduce ಆಕೋತ ಹೋಗ್ತದೆ. When the axis of analyzer becomes perpendicular to the axis of polarizer, when the axis of analyzer becomes perpendicular to the axis of polarizer, the output intensity which we are getting from analyzer will become 0, right? ಅದು ನಮಗೆ 0 ಆಗ್ತದೆ. Okay, that's why depending on the angle, the output intensity of analyzer will be there. So how much will be that intensity? It will be I naught by 2 cos square pi. I naught by 2 is the intensity coming out from polarizer into cos square pi. So that angle between axis of polarizer and axis of analyzer matters, that is pi. If that is 90 degree, then the intensity coming out from the analyzer will be 0, right? So this is the intensity coming out from analyzer. Okay, that's all about how is the relation between the analyzer and polarizer, how the intensity will come out. Okay, the last thing is, see, this is polarization by reflection. Polarization by reflection. This is the incident ray which is unpolarized. This is the incident ray which is unpolarized. We have incident this unpolarized light at an angle of at an angle called as polarizing angle. Polarizing angle ಒಳಗೆ ನಾವು ಇನ್ಸಿಡೆಂಟ್ ಮಾಡ್ಕೊಂಡಿದೀವಿ. See, ಎಲ್ಲ angle of incidence ಅದು polarize ಆಗಂಗಿಲ್ಲ. For 10 degree it will not be polarized, for 20 degree it will not be polarized. If for 30 degree it is polarized, that is called polarizing angle. So polarizing angle is angle of incidence. ಯಾವುದೋ ಒಂದು angle ಲೈಟ್ ಪೊಲರೈಸ್ ಆಗ್ತದ್ರಿ, ಅದಕ್ಕೆ polarizing angle ಅಂತ ಕರೀತಾರೆ. ಈಗ ನಾವು ಈ ಲೈಟ್ ರನ್ನ polarizing angle ಒಳಗೆ ಇನ್ಸಿಡೆಂಟ್ ಮಾಡ್ಕೊಂಡಿದ್ವಿ. A part of light will be reflected and a part of light will be refracted to the next medium whose refractive index is n. When the angle of incidence is equal to polarizing angle, at that time the reflected light ray will be 100% polarized. But ಇಲ್ಲಿ angle of incidence ಎಷ್ಟು ಇರಬೇಕು? Angle of incidence ನಮಗೆ polarizing angle ಇರಬೇಕು. ಎಕ್ಸಾಂಪಲ್ ನೋಡ್ರಿ, ಸಪೋಸ್ ನಮಗೆ angle of incidence 10 degree ಇತ್ತು, 10 degree ಇತ್ತು, ಅವಾಗ ನಮಗೆ 100% polarized ಸಿಗಲಿಲ್ಲ. ಲೆಟ್ ಮಿ ಸೇ ಇಟ್ ಇಸ್ 50% polarized ಅಂತ. If I take angle of incidence 20 degree, angle of incidence na 20 degree ತಗೊಂಡ್ರೆ ಇದು ನಮಗೆ 80% ಆಯ್ತು ಅಂತ ಇಟ್ಕೊಳ್ಳಿ. And for angle of incidence 30 degree, let me say that reflected light, ಇದು reflected light ರೇ, reflected light 100% polarize ಆಯ್ತಪ್ಪ ಅಂತಂದ್ರೆ, then this 30 degree is called as polarizing angle. ಇದಕ್ಕೆ ಮಾತ್ರ ನೀವು polarizing angle ಅಂತ ಕರೀಬೇಕು. 20 degree, 10 degree are not polarizing angle, right? So polarizing angle means the angle of incidence at which the reflected light ray will be completely polarized. ಇದು ನೋಡ್ರಿ 100% polarized ಆಗಿದೆ. There are only vibrations which are perpendicular to the plane of the board here. No other type of vibrations are present, correct? But refracted light ray ನೋಡ್ರಿ, it is not completely polarized. ಇದು partially polarized light, partially polarized light, right? So remember, when the light ray or when the incident ray is incident at an angle, polarizing angle, reflected light ray will be 100% polarized, refracted light ray will be partially polarized, and reflected ray and refracted ray both will be perpendicular to each other. ಇವೆರಡು ಒಂದಕ್ಕೊಂದು perpendicular ಇರ್ತವೆ. So here you can take theta p ಅಂತರ this angle. ನೋಡ್ರಿ, according to law of reflection, angle of incidence ಎಷ್ಟು ಇರ್ತದೆ, angle of reflection ಕೂಡ ಅಷ್ಟೇ ಇರ್ತದ್ರಿ. So theta p plus 90 degree, ಇದು ನಮಗೆ 90 degree, plus ಇದು angle of refraction plus angle of refraction, together this will be 180 degree, right? ಇದು ನಮಗೆ 180 degree ಇರ್ತದೆ. So 180 degree ಒಳಗೆ ಮೂರು angles ನಮಗೆ theta p, 90 and r, right? This much will be the angle, right? ಇದೊಂದು relation ನೆನಪಿಟ್ಕೊಳ್ಳಿ. And by this we will get a relation between refractive index of the material n and polarizing angle. N is equal to tan theta p. This is the relation between refractive index and polarizing angle, right? Okay, so dear students, that's all about wave optics, right? Dear students, if you like the content of this channel, please don't forget to subscribe the channel and share the video, share the channel with your friends. Please refer the videos, please refer the channel for your juniors as well as for your friends, right? So this is all about wave optics. In the next video, we'll do dual nature. I'm thinking about combining atoms and nuclei. So in 3 or 4 videos, we'll complete the entire second PUC physics, right? So soon we'll come up with the next video also. And please don't forget to subscribe and share the channel. We'll meet again in the next video. Thank you so much for watching and subscribing the channel. Please keep watching and supporting the channel. Thank you.